Good day! In this video, we will learn how to conduct supervised machine learning using WEKA. But first, what is supervised machine learning? Supervised machine learning is a type of machine learning where the model learns from labeled data to predict future instances. Common algorithms that is available in WEKA are the following. We have decision trees, naive Bayes, k-nearest neighbors, and support vector machines. However, it depends upon your dataset. Now, let's proceed on how to do supervised machine learning in WEKA. Again, let us load or open our WEKA and then click our Explore button. Once our WEKA Explorer is open, let us now open our dataset that we previously converted into the .arff format. So click Open File, then go to your folder. In my case, it's in my desktop folder in WEKA subfolder, and this is my converted dataset in .arff format. I just selected it, then click Open. Now, I would like to introduce you or orient you with the pre-process interface. So, in here, you can see the current relation, which is the database diabetes dataset raw data, which is also the file name. Then there are 10,040 instances or records. Then there are 22 attributes, or let's say your variables. Okay. Then in here, you can see all your variables. So you have the variable diabetes binary, high BP, and so on and so forth. At the right side, you can see the minimum value and the maximum value, and also the mean and the standard deviation of your selected attribute in the left side. Okay, so as you can see, and this is the histogram of your variable. Okay, so as you click select another variable in this left side window, okay, it changes. So as you can see, BMI has a minimum value of 13 and has a maximum value of 92. Okay, so in order for us to analyze better and make a supervised machine learning model more accurately, we need to normalize our data. But first, meaning normalized, we should all of the attributes, we should set their minimum and maximum with the same. All of them should have been the same minimum and maximum. As in our case, it is based on our diabetes binary. So it should have only value 0 between 0 and 1. So BMI should be converted or normalized into values ranging from 0 to 1 only. Okay, but before that, okay, let us first make, among our attributes, let us first make it a class. Okay, as of now, our class is income. So our class is the dependent variable. It is what we predict. So in our case, it's not the income, but rather the diabetes binary. So to set your class into diabetes binary, just click the edit button here, and then just hover your mouse in your dependent variable. In our case, it's the diabetes binary here. Then right click and then select the attribute as class. When we click it, this diabetes binary will go to the last column. Okay, so I will click this attribute as class, and as I have said, it became our class, and it was transferred to the last column, signifying that it is our target variable, or it is our dependent variable, or our class variable. the variable we want to predict, whether the patient has diabetes 0 or I should say the patient has no diabetes 0 or the patient has diabetes 1. And then after that one, we can now click the OK button. And as you can see, the class here uh, from the income a while ago, it now became diabetes binary. Okay, so after setting your class, we now proceed to normalize our values. As I have said a while ago, normalizing values would allow us to accurately make predictions and accurately make our supervised machine learning model. For example, this BMI with a minimum of 13 and a maximum of 92 should have also a minimum and maximum of 0 and 1, since all of the variables should have the same minimum and maximum number. For example, this general health should also be 0 and 1. This one also, the mental health, 0 and 30, as well as physical health and all. Okay, so to do that, except the diabetes binary attribute. So to do that, just uh, click here in the filter, just select or click the choose button here, then click this arrow, the filters, to expand the filter folder, then under which is the unsupervised, and then the attribute, and then we select the normalize here, this one, normalize. Okay, so you are you know that you click it when you already see this normalize uh, text here, and then just click the apply button. Then after which you have to double check. So as I have said, all of your attributes should have a minimum value of 0 and a maximum value of 1, so that they have the same values. They can be compared. They can be analyzed. Okay, let's check it one by one. High cholesterol, check. And then, as you can see, our BMI was already normalized with a minimum value of 0 and 1. So we can scroll down one by one. Then our general health a while ago, it became now 0 and 1. And that's it. Okay, so we are ready to perform classification supervised learning algorithm. So to do that, click the classify here. And then I would just like to introduce you to the interface of the WEKA Explorer in the classify tab. So this is where we perform our supervised machine learning algorithm to create our supervised machine learning model. So in here, you could choose the classifier. Just click this choose, and as you can see, the WEKA will suggest what appropriate classifiers or supervised machine learning algorithms you can use in your data set. If it is not, if it is grayed out, or it means it cannot be applied in your data set. Like for example, the naive Bayes cannot be performed in your data set. So as you hover over the particular algorithm, there is a help, okay, help or description of the classification algorithm. Okay, so in this case, Bayes algorithm are not applicable in our data set. We have the functions algorithm, the Gaussian. Okay, it's highlight. It can be highlighted. It's darkened. So all of the darkened algorithms can be applied in your data set. All the lighted ones cannot be applied. Okay, so for example, you choose the logistic. So the start button cannot be applied because it is not applicable in your data set. While Gaussian process, it is applicable because you can click the start button. Okay, so next, after choosing, so let's choose linear regression. After choosing, you have this test option. So if you want to use the training set, click here. Okay, if you want to use the cross validation, which has 10 folds, meaning if you have a data set of 1,000, you will divide the WEKA will divide your data set into 10 segments. So 100 divided by 10, you will have 10 parts or 10 segments containing 10 data points per segment. Meaning, for example, your data record number 1 to 10 belongs to set number 1, 11 to 20 belongs to set number 2, and so on and so forth. So what WEKA will do is that 9 sets will be used as a training set, and 1 set will be used as testing data set. For example, and tenfold meaning the system will run it 10 times in order to get the best performing machine learning model. So for example, as I have said, if you have 100 data sets, it will be divided into 10. So set A or set 1 is record number 1 to 10. Set 2 is record number 11 to 20, and so on and so forth. So for the first run, the machine will try to use set 1 to 9 as your training data set, and set 10 is your testing data set, and it will produce your performance evaluation matrix. Then on the second run, it will utilize the set 2 to set 2 to set 10, while it will utilize the set 1 as testing data set. And again, the machine learning will produce performance matrix of that training and testing set, and then and so on and so forth until all the sets became the testing data set. Okay, I hope we are clear on that. Then we can also choose percentage split. So in here, we specify the number of percentage of how much of the training of your data set will be treated as your training data set. So in best practice, we divide our data set into training and testing. Okay, so we need to train the data set in, into 80%. So let's say 80%. If you put 80% here, that means the testing data set would comprise 20% of your data set. So it is important that the data that is used in training should not be used in testing, so that it will not be biased for the machine learning. It will not overfit. That's why we are splitting the data set into 80%. So for example, you have a data set of 1,000. Your data set, your training data set comprises of 80%, meaning 800 data or records will be used for training your model, and 20% or 200 records or data will be used as testing your machine learning model. Okay, so in this example, we will first try for the cross-validation folds. So you just select this one, and then we will just use the default values since we are only after the basic machine learning model. Then once you have selected, so you select your classifier here, you select the test option here, and we click the start button. Okay, once we click the start button, you will now have our classifier output. So there is the run information, okay, the instances or the number of records. We have 10,040. We have the different attributes, and we have the test modes. We have the tenfold cross-validation. And as you scroll down, you have your classifier model already. So this is your classifier model. Your classifier model is a linear regression model. Okay, it tries to predict diabetes binary. Then these are the correlation coefficient according to the variables. And as you go down, here is your cross-validation summary or your machine learning algorithm performance. We have the correlation coefficient has a 0.5613, mean absolute error 0.3504, root mean squared error 0.4129. We have your relative absolute error of 70.3632%, root relative squared error 82.7513, and the total number of instances. So in a separate video, we will discuss further what does this machine learning performance is all about, or does it means, no? So this is the one you will use to assess or evaluate your classifier. Okay, and compare them to other classifiers. Okay, so we can compare either one classifier with different test options, or we can also choose another classifier. So before we choose another classifier, we will choose another test option. So this time we try to evaluate if we use the percentage split of 80-20, which means 80% testing and 20% I should say 80% training and 20% testing. Then let's start it. When you click the start, it will be added here. So in this result list, these are your machine learning algorithms or machine learning model. So this is our first machine learning model a while ago, which is the linear regression model that has undergone tenfold cross validation. Now let's see. So take note, the correlation coefficient here is 0.5613. So let us take a look if it has a higher or lower when we did the test option of percentage split. So let's go to the second one. So this time, this is your linear regression model, and this time it was split into 80% training and 20% testing data set. So the performance of the model correlation coefficient seems to be increased because a while ago it's 0.5613 and this time it's 0.5742. So you can compare now which is the model, which model is best or better in predicting whether a patient has diabetes or not in our data set. So I hope we are clear on this. So let's try if we use the training data set. Let's click it. Okay. So again, the name of your machine learning model, your supervised machine learning model is linear regression model, test mode, evaluate on rating data set. So let's take the performance. It has a correlation coefficient of 0.5633. So it seems that it is better than the linear regression with tenfold cross-validation. So among the three methods of the linear regression, I think the best one is the correlation coefficient. So this is one way of comparing which classifier is better, no, in predicting your diabetes mellitus risk. Okay, so this is what we are doing. So let's say so our goal here, that's why we are training and testing and we are evaluating our performance model. Our goal here is to know which model, which test options are best to use, no? Or that as a supervised machine learning model in predicting our data set. Okay, so let's choose again. So click choose. And then let's say, for example, we will try to use trees. This time, random forest. Then we will start with cross-validation, 10 folds. Okay, this is the best practice. You use 10 folds. So then click start. Okay, depending on your data, on your computer resources and the data set, your computer resources. Okay, you can see depending on the machine learning algorithm also. So as compared to the linear regression a while ago, your random forest is building uh, the model longer. So in here in your status, you can see it. You can see the real-time status. So at this time, the building model for fold 6 already done. Then if the WEKA bird is turning here, means it's loading. And if you have encountering uh, bugs or hangs on your computer during this step, just click the stop button here. Okay, now we now have our summary. Okay, so you can see that it's already done inputting or creating your model if the status is okay and the bird stops already here. Okay, so as you can see, your model name is random forest with the test mode of tenfold cross validation. So it has a correlation coefficient of 0.5455. And then you can also compare it to the used training set. Again, click start. And again, please bear in mind the status. So building model on training data. Then the bird is turning right from left. Okay, so you can tell that the time taken to build your model here. Okay, so this is the performance model of your random forest with the test mode of evaluating on training data set. So as we can see, it has a very high correlation coefficient of 0.9697 as compared to the other 1, 2, 3, 4 previous machine learning algorithms we have already trained. Okay, so when you click the start button here, it means that you are training now your machine learning model for your data set. Okay, so let's also try the percentage split. Then let's click start. So the status is again building model and training data times 1. Okay, then we wait for it to be built. Okay, so we wait for the status here. Okay, so it's okay now. So as you can see, again, the name of your model is random forest with the test mode of splitting into 80% training data set and 20% training data set. Okay, so you can also experiment which is higher. So as you can see, using these settings, you have a 0.5596 correlation coefficient. And if we try to adjust the training data set, okay, so so for our basic machine learning, so we can have these default settings. Okay, so as you can see, we are waiting for it to be finished. Okay, so it is a correlation coefficient of 0.5542. So in your activity, you need to compare different machine learning algorithms and interpret the results. Okay, so in here, 1, 2, 3, 4. So it seems from the random forest classifier, the best one is the random forest evaluated on the training data set. But of course, if you use the training set, it will also all use your data set as a training data set. Okay, then you can choose another one. Let's say, for example, a function, it's already yan. So you can explore. Okay, for example, we want to have this LBK. So you can read what LBK means. Then click start. Okay, here, okay, there is another performance metric. Again, what is your algorithm or your machine learning model? Your machine learning model is IB instance-based classifier. We're using one nearest neighbor for classification with the test mode of split 70% trained data, 30% testing data. Okay? So that's it. So in supervised machine learning algorithm, we compare their correlation coefficients, mean absolute error, root mean squared error, and so on and so forth. So in the next video, we will try to analyze what does each uh, performance metric means. Okay, so this is for now in our model. Thank you for listening.